All right, y'all. So section 7.1 deals with symmetry. And we'll be looking at three types of symmetry today. So the first type of symmetry is what we call symmetric to the y-axis. So, when something's symmetric to the y-axis, that y-axis sort of cuts that graph into two equal halves. So the y-axis cuts the graph into two equal halves. So if folding along the y-axis, the right side of the graph will land exactly on the left side of the graph. Okay, so you'll fold it over the y-axis. If it lands right on itself, then it is symmetric to the y-axis. Now, graphs that are symmetric to the y-axis, we say that these are what we call even functions. So they are even functions, and that also means that these graphs cross the x-axis an even number of times. Alrighty, y'all. So symmetric to the y-axis, an example of that would be a parabola that we've been drawing. So if I was to take my graph and fold it right over that y-axis, this right side would land on the left side. So that is being symmetric to the y-axis. So the second one would be symmetric to the x-axis. So basically the x-axis will cut the graph in half, giving you a top and a bottom. So it's going to cut the graph into two equal parts. And if folding along the x-axis, and the top side lands exactly on the bottom side, okay, so I'm folding along the x-axis, the top of my graph lands right on the bottom of the graph, okay? Alrighty. So these are called um, symmetric to the x-axis, okay? So let me show you one of these. So this would be if I had, say, a parabola going sideways. So if I was to take this graph and fold it over the x-axis, the top of my graph will land exactly on the bottom of my graph. Now, the y-axis was an even function, but y'all, this is not even a function, remember, because this fails the vertical line test. Okay, so if it's symmetric to the x-axis, these graphs are not a function. All right, y'all, then we got our third type. And this is symmetric to the origin. Now, this one don't get divided in half or nothing. If it's symmetric to the origin, if I take the page and I turn it upside down 180 degrees and you have the same picture, then it's symmetric to the origin. So if rotating the graph 180 degrees and we have the same picture of a graph, okay, so I take my page, I turn it upside down. If the graph looks the same as when it started, then it's symmetric to the origin. Now, these are odd functions. So what that means is these graphs cross the x-axis an odd number of times. So y'all, an example of an odd function would be like the cubic graphs we draw. They sort of come up, go through the center, and then go up. But if you take this graph and turn it 180 degrees, so look how it's going uphill, left to right. If you was to turn it upside down, the graph is still going uphill, left to right. So that's what it means to be symmetric to the origin, is when you turn it upside down, your graph looks the same, okay? And like I said, these are odd functions. Symmetric to the y-axis is an even function. So what we're going to do, we're going to go look at the problems in MATLAB and see what y'all think about them. All right, y'all, so we got three choices here. They want to know if this is symmetric to the x-axis, y-axis, and or the origin. So we'll check the y-axis first. Well, if you fold it along the y-axis, the right side will not land on the left side. So it's not the y-axis. So we'll check the x-axis. We'll fold it along the x-axis. Well, y'all, the top of the graph is not going to land on the bottom of the graph. So it's not symmetric to the x-axis. So Hamza, what you got, a D? So we're going to go with D. Because y'all look at this. This graph goes downhill, then uphill, then downhill. If you turn this 180 degrees, it'll look exactly the same. So since it looks the same when I turn it upside down, it's symmetric to the origin. All right, y'all, let's see what y'all do on number 2 here. So would we say number 2 is symmetric to the x-axis, y-axis, origin, or it even has both the x and the y? So y'all start out with the y-axis. If you fold it over the y-axis, will it land on itself? And it will definitely land on itself. So it's definitely symmetric to the y-axis. Now, y'all, the x-axis, there's not even a part on top of the x-axis, so it can't be symmetric to the x-axis because the x-axis is not cutting it in half. Okay, so remember if it's symmetric to that axis will cut it in half. So there's no way it can be to the x because we don't even have the graph on top of the x-axis. The origin, if you was to turn it upside down, well, the graph wouldn't be at the bottom like it is. It would be at the top. So it wouldn't look the same. So y'all, the only possible answer, Olivia, you got it, would be the y-axis. So what are y'all thinking on this one? Y-axis. So first they want to know, is it symmetric to the x-axis? So that's a yes or no. And yeah, if you fold it along the x-axis, the top part of the graph will fall on the bottom part of the graph, so that'd be a yes. Is it symmetric to the y-axis? So if we folded it along the y, would the right half land on the left side? So that's a no. So good job, Olivia. That is definitely a no. Is it symmetric to the origin? If we turn this graph upside down, would it be pointing to the right like it is? And y'all, that's also going to be a no. Because if you turn that upside down, instead of looking like a greater than, it'll look like a less than over there, okay? So that is definitely a no. So that one was only symmetric to the x, okay? You know, so these are even and odd. Remember, if it's symmetric to the y-axis, it's even. If it's symmetric to the origin, it's odd. So this one is symmetric to the y-axis. Good job. Olivia, if I fold this right side over, it'll land on the left side. And if you notice, it's touching the x-axis 2 times down there. And since it's touching the x-axis twice, that's an even number. So this is definitely an even function. All right, y'all, then let me do this one here a little bigger. So even or odd? Symmetric to the y-axis, or is it symmetric to the origin? And y'all, good job. That is definitely odd. Because if you take that picture and turn it upside down, it'll look like the exact same graph. And if you notice, it's touching it 1, 2, 3, 4, 5, 6, 7, 8, 9. It's touching the x-axis 9 times, which is also an odd number. So odd functions will touch the graph on the x-axis an odd number of times, okay? All right, y'all, that's it on that's 7.1. So 7.1 was mainly just doing them 5 graphs, seeing if they're even, odd, symmetric to the y-axis, x-axis, or the origin, okay? So y'all got any questions off that section? Okay, y'all, so let me tell you about 7.2 here. 7.2 deals with transformations. So we're going to be looking at 7 basic graphs. And what we'll do to them 7 basic graphs, we're going to see how do you move them up and down. How would you move them left or right? Or even how would you reflect them? Okay, so those are going to be the main moves we do to these graphs. So basically, let's start out with looking at the 7 basic graphs. Now, y'all, in week 2, in the week 2 folder in Blackboard, there's a sheet that says basic graphs on it, so you'll have access to them on that also. But I'm actually going to draw the 7 graphs for us. So the basic graph number 1 is a line. And the basic line graph is a straight line going through the center of the origin. This is the graph of y equals x. If x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. And so on. This is the most basic line graph there is. The second basic graph. And we've been drawing these a little bit. The second basic graph is your U-shaped parabola. And we got those when we had x squared graphs. Quadratic graphs or x squared graphs create the U-shaped parabolas. So that's the basic graph for the x squareds. All right, we've done cubes. So remember, the basic cube graph came up, went through the center, and then went uphill. So this is your y equals x cubed. Okay, so 3 of them. So we got 4 more. All right, y'all, this one would be the square root of x. So the square root of x graph, it starts in the center and it just slowly tries to go uphill as it heads off to the right. So this is y equals the square root of x. Like square root of 1 is 1, square root of 4 is 2, and so far. So it's a slowly uphill graph to the right. All right, we got a cube root. Now, cube roots are similar to the um, square roots, except cube roots can go in the negative direction. I can take the square root of a negative number and get a negative answer. Over here, on square roots, you can't take square roots of negative numbers. That's why this graph ain't on this side, okay? Well, the next one we played with a little bit, it's the V-shaped graph. And the V-shaped graph was the absolute value. So this would be y equals absolute value of x. Oh, y'all didn't put this one here. This one was a cube root. So the basic absolute value graph starts in the middle. We're going to learn how to move it around, like I said, in a second. All right, y'all. So this last one is the what we call a reciprocal graph. And we'll learn about this last one more when we hit the third module. But this one on the left side comes down like that, and then on the right side comes down like that. This is the y equals 1 over x graph. Now, you don't have to do nothing to these in this section except we're going to learn how to move these graphs up and down, left and right, and flip them over to x-axis, okay? So there's going to be 3 transformations we're looking at. But these are the basic graphs we're starting with, okay? The y equals x squared, y equals x cubed, y equals square root of x, y equals cube root of x, y equals the absolute value of x, and then y equals 1 over x. Okay? So these are the basic graphs we're moving around. So let's start looking at our transformations. All right, the first one is a vertical transformation. So vertical, I'm either going to move it up or I'm going to move it down. Okay, so y equals f of x plus or minus b. So here's my function, like x squared plus or minus b. I'm either going to add or subtract a number at the end. If adding b, then graph goes up. So if this is positive at the end, your graph is going to go up, ever how many numbers that is. If you're subtracting b, so you're minus some number, you're subtracting it from the function, then the graph goes down. Okay, so adding or subtracting, up or down, okay? All right, so an example of that would be y equals x squared plus 5. So on this example, I'm adding 5 to the end of the function. So what's going to happen here, the x squared graph moves up 5 units. Okay? Now, if that was minus 5, the x squared graph would move down 5 units, okay? So you're just adding or subtracting a number at the end of your function. All right, y'all, we got a horizontal transformation. Horizontal is going to move me left or right. So to get that type of effect, you're going to have y equals f of x plus or minus a. Now notice the difference. I didn't add the number to the end of the function. I'm actually changing the x values of the function. Okay? So it's a big difference on here. This is inside parentheses. This is added at the end of the function. So if we're adding a, so if I got something like f of x plus 2 in here, if I'm adding a, it's not going to make the graph go right. It's actually going to make the graph go left. So the graph goes left. When you add a number to the x value, it's going to go left. If you're subtracting that a, If subtracting the a, then it's going to go right. Now I'm going to do an example similar to that. I'm going to do y equals x plus 5 squared. So notice the difference. Up here, I added 5 at the end of the x squared function. I didn't change the x at all. Right here, I'm changing the x value before it gets squared. So if you're attacking the x like that, that's going to go left to right. So remember, we said if we're adding a number to the function, it's going to go left. So this would be the x squared graph. It's still the x squared graph because you got the exponent 2 here. So the x squared graph moves left 5 units. So I wanted to do the same type problem, but I wanted y'all to see the difference where I'm putting the number. Am I adding it to the end or am I attacking the x's on that function, okay? All righty, y'all, the third move is a reflection across the x-axis. And the way I'm going to reflect over the x-axis, I'm going to have y equals negative f of x. So by putting a negative in front of your function, it's going to reflect it over the x-axis. So doing with the x squared again, I would have y equals negative x squared. And when y'all did the x squared graphs in the first module, if it was negative in front, it turned it upside down, okay? So this one will reflect the x squared graph over the x-axis. Okay? Now, in MATLAB, when we do the homework, they're going to ask us for what basic graph we're starting with. So we got to tell them which one of the 7 basic graphs we're starting with, and then what's happening from what they're doing to it. Are they moving me left or right, up or down, or are they reflecting me, okay? And then I'll show you how to actually graph these in MATLAB. So y'all let me go to pull up 7.2 real quick. All right, so we got about 8 of these. Um, so on these, we're going to choose what basic graph is and then what the moves are doing. So like on number 1, y equals parentheses x plus 1 squared. So we know we're starting with the x squared graph because of that exponent 2. So before we choose A, B, C, or D, we got to know what that plus 1 is doing to my graph. So notice I'm inside the parentheses with that plus 1. And we said when we're inside the parentheses and we're adding to the x, it's either going to go left or right. So since that is a plus 1, we said if you added 1 to the x inside the parentheses, it would move it left. So I would come down here and choose C that says move it 1 unit left, and I would tell it what the basic graph is I'm starting with, and that's going to be the x squared graph. So you tell it what graph you're starting with, and then we said 1 unit left. You're going to check that answer. Then it wants us to graph it. So y'all, here's where you got to know what the shapes look like. So you're going to click the enlarge graph. You got to figure out which tool you want to use. Well, we know that the x squared graphs make a U-shaped parabola. So we're going to grab the x squared tool, and you can click it anywhere on the graph over here. It'll always start it in the middle. Now y'all see it opened up a little box. So we said we were going to shift it 1 unit left. So you come down here to the horizontal shift and you move that left 1 unit. It automatically moves the graph left for you, okay? Now, on this little box that pops up, we're not going to do vertical stretch and shrink. We're not going to do horizontal stretch and shrink. We're not doing neither of those on the top, okay? We're only going to do the vertical shift, horizontal shift, and reflect it over the x-axis. We will not reflect anything over the y-axis, okay? So it's horizontal, vertical, or reflect over the x. So y'all, since I moved my horizontal one to the left, I would save that, and then you check your answer. All right, so this is the only one where you actually got to plot points on it because it's the line graph. Um, so this is like y equals x. It's the line graph. So that minus 10 at the end of the function on this one is going to shift me down 10 units. So I would go to the one that said shifting it down 10 units. And then I would start with the y equals x graph. It's always going to be one of them 7 basic graphs, okay? So on this one, you check the answer, and then it wants us to graph it. But y'all, since this one's the line tool, we physically got to plot 2 points, okay? So let me see, I'm going to grab the line tool. So let's see, if I put a 0 in for x, I get 0 minus 10, which is negative 10 for y. So I got 0, negative 10. So that'll be 1 point. And then let's say I let x equal 10. So if x equals 10, I got 10 minus 10, which is 0. So let me go to 10 for x and 0 for the y and click that. But notice, the graph used to cross right through the center. Now it's 10 units down, okay? So that's the only one you physically got to graph is the one with the line. So y'all, you're going to save that, check answer, and move on. All right, y'all, so this is the graph of h of x equals 1 over x plus 4. So what is that plus 4 doing to this graph? Up, down, left, or right? Now notice, I'm not adding 4 to the x on it. I'm adding it at the end of the function. So anytime we add to the number at the end of the function, you're going to go up or down. All right, y'all, so that's up or down. So which one is it? Plus 4, we said, would move me up. So y'all, that one's going to go 4 units up, okay? So check your answer. So let's look at these 3 pictures. And we got to pick which one went up. So it looks like A went down. B is the basic graph, right? That's the one we drew a while ago for the basic graph. So B is the actual basic graph. So look at C. C looks like everything shifted up. So, Humps, I'm going to go with you. I'm going to go with C on that one, okay? All right, y'all. This one's got two moves. I got a negative in the front, and then I got that plus 8 being added inside the parentheses. So remember, if you're attacking the x inside the parentheses before it gets cubed, it's either going to go left or right. And since we're adding 8, that's going to make it go left. So I know it's going to go left. So what's that negative in the front doing? Well, that negative in the front is going to reflect it over the x-axis. Remember, we're not even reflecting anything over the y-axis. So you can forget about A and B on that one, okay? Because both of them have y-axis. So it's going to be the x-axis. And we said we're moving left. So what do y'all got? D. And then remember, you're starting with the graph of x cubed. So you draw that and then put in an exponent of 3. So you got to tell them what your starting graph is on some of these. And then pick the one that had the right moves, okay? All right, so we said we're going left 8, reflect over to x. So check answer. So y'all now will actually have to graph it. So I'm going to pick the enlarged graph. Remember, that's a cube. So we want the little squiggly X cube tool. Click on that one and then click anywhere on your graph. Okay, so that's why you want to keep those 7 basic graphs handy. Because when you see that cube on that, you want to make sure it's the one that looks like the squiggly line, okay? All right, y'all. So you said we're going to go left 8. So I'm going to grab that horizontal and go left to negative 8. So it moved my line left. And then we said we're going to reflect it over to X. So you come down to the bottom and you check the box and it flips the graph over. Same thing. And then check your answer. All right, y'all. So let's see what we're doing here. G of x equals x plus 5 squared plus 2. We're going to start with the graph of x squared. Now it says shift it blank 5 units. Well, that 5 is being added to the x inside those parentheses. So is that going to go down, left, up, or right? Good job. Since we're adding to the x, it's going to go left. So you click left. And then shift it blank 2 units. So you got a plus 2 at the end. Is that right, up, left, or down? And y'all, that would definitely be up. Okay, so as long as you remember the ones in the parentheses are sort of backwards from what you would think, these aren't bad, okay? All right, y'all, so we're going to check that answer. It's okay. So now click the enlarge graph. So we're going to grab the x squared tool, click anywhere over here. You said left 5, so y'all, that'd be a horizontal. Go left to negative 5. And then you said up 2. So go to vertical and go to positive 2. So y'all look at that. It moved it left and it moved it up. And then we save it. All right, y'all, I'm going to check my answer and head to the next one. Y'all, this one's sort of tricky, so let me explain something. This is f of x equals square root of x plus 2. If the number is under the square root, we treat square roots like they are the same priority as parentheses. So if the number is under the radical, it's like it's in parentheses. Otherwise, they would throw the number outside of the radical, okay? So it says start with the graph of g of x equals square root of x, then shift it. So since that's under the radical, it's like it's in parentheses. And when you add to the x before you take the square root, it's going to move us left. And then that would be what? Left 2 units on that, okay? So remember, under the radical, like parentheses, outside the radical would be your up and down, okay? All right, y'all, so remember, it's going to go left 2 units. So which one of these graphs is the square root graph, and it went left 2 units? So y'all picking A, B, C, or D? Now remember, the square root graph started right in the center of the origin, okay? Hey, y'all, so let's look at them. Looks like A went down just a little bit, so it's not A. B looks like it went right a little bit, so it's not B because y'all said left. So what do y'all get? D, so I think y'all are right because it looks like C went up. And then D, if you look at it, looks like it's a little bit left of the center. So y'all, I would pick D like y'all and check that answer. Now see, here's a different one. See, that square root one had that number under the square root radical. But y'all, this one, the -6 is outside the radical. So it's going to move the cube root of x when you subtract 6 at the end of the function. Am I going to go up, down, left, or right? That's the question. So definitely going to go down. Good job. Now, if that -6 would have been under the radical, it would have been the left and right stuff, okay? But remember, if it's outside the radical, at the end, it's going up or down. All right, so that's going to go 6 units down. So, which graph is the cube root went down? You got A, B, or C? So yeah, I'm going to go with Livy on that. And you said B, because B looks like it went down. A looks like it went up. And y'all C looks like the basic graph going right through the origin there, okay? So the only one that went down would have been B on that one. Oh, y'all, this one's got 3 moves on it. You got the negative in front. You're subtracting 5 from the x. And you're adding 3 at the end. So let's see what we're starting with. So they actually going to start with that, what's that -5 doing to me? Because they're looking at the left and right stuff here, right? So if you subtract 5, are you going to go left 3, right 5, left 5, right 3? So we're going to go right, y'all are saying, so click right 5. Remember, that is always sort of opposite of what you think. All right, what are you putting here? Reflected across the y-axis or the x-axis? All right, Ben, that's definitely going to be the x-axis. And then you're going to shift it. What's that +3 doing? Down 5, up 5, down 3, up 3. All right, y'all. So y'all are saying up 3 on that one. Good job. Now this one, we just got to check the answer and be done. So the last one you didn't actually have to graph. They just wanted to hit you with all three moves at once and see what you did with that, okay? All right, y'all, so let me ask y'all, any questions on those? And that's basically today's lesson was the symmetry. You had your three types of symmetry, y-axis, x-axis, and your origin. You had your seven basic graphs, and we did three transformations. We went vertical up and down, horizontal left and right, and then we reflected across the x-axis. All right, y'all. So let me see. I'm not seeing any questions.